Of all the astronomical processes observed in nature, perhaps none offer more emphatic evidence in favor of plasma cosmology and the electric universe than star formation. This is true experimentally and observationally, and as the scientific data grows ever finer, the evidential case for electrical star formation grows with it. The electric universe agrees with the plasma cosmology concept that stars form by the electromagnetic Z-pinch, or Bennett pinch, along Birkeland current filaments. This is in stark contrast to the standard theory of stars forming by gravitational collapse and accretion in isolated cores. Today, let's explore what new observations tell us about the respective theoretical successes of the electric universe in plasma cosmology and standard astronomy. Recently, a scientific paper in the journal Science Advances explored the critical role of Birkeland currents in the formation of stars. Unfortunately, however, this of course is not the language nor the conceptual framework that the authors of said paper have utilized. Rather, they use the outdated, inappropriate language and concepts of kinetic gases and mechanical winds. Indeed, quite incredibly, the word plasma never once appears in the scientific paper, entitled "Massive Extended Streamers Feed High-Mass Young Stars." Instead, the word gas appears to serve as a substitute for plasma throughout the entire paper. However, plasma, which NASA scientists have long recognized composes more than 99% of the physical universe, is not a, quote, hot gas that conforms to kinetic gas laws. Plasma is the conductive medium through which charged particles flow throughout the cosmos, and the study of the movements of these charged particles is called electrodynamics. A science press release from Kyoto University describes some truly stunning observations obtained by the ALMA telescope, which, quote, revealed a young star feeding from potentially two streamers. One such streamer was connected to the central region of the star, with a velocity gradient indicative of rotation and possibly infall. This suggests that the streamer carries enough matter at a high rate to quench feedback effects from the young star, eventually contributing to the overly dense region observed around the central massive star. The research team expected to see a dust disk, or torus, of several hundred astronomical units in size, but they did not expect the spiral arms to reach far closer to the central source. We found streamers feeding what at that time was thought to be a disk, but to our surprise, there was either no disk or it is extremely small. The lead author of the paper summarizes, "Our work seems to show that these structures are being fed by streamers, which are flows of gas that bring matter from scales larger than 1,000 astronomical units, essentially acting as massive gas highways." Of course, the travelers on the cosmic highways along which stars form, those stupendous networks of filaments of constant width across light years, are networks of electric currents flowing through the conductive medium of plasma. Birkeland currents rotate, so the evidence of rotation by the, quote, streamers contributing to the star's formation is not surprising. For that matter, it was not surprising a few years ago when rotation was also observed in the filaments composing the so-called cosmic web. Unfortunately, it is equally unsurprising that astronomers, who are not professionally required to understand plasma physics and the principles of electric circuit theory, do not recognize the signature of a Birkeland current even when it's self-evident. The problem here is truly fundamental. I'm reminded of one of my favorite truisms uttered by Wal Thornhill. Nature does not do things the hard way. In the gravitational theory of star formation, the number of problematic discoveries over decades are far too numerous for me to cite in a single presentation. I will mention, though, a similar discovery from a few years ago, which shows the increasingly devastating problems that so-called protostars are presenting as astronomers are able to get a closer and closer look. In 2021, scientists studied a group of over 300 protostars in a star-forming region called the Orion Complex. Much to their surprise, they found that so-called gravitational cavities do not play their predicted role in quenching the growth of a star. Conventional theory predicts a type of so-called stellar feedback involving astrophysical jets and stellar winds, which would pull gas from a star and trap it in its molecular cloud, eventually halting a star's growth. However, as Dr. Noel Hobble stated, In one stellar formation model, if you start out with a small cavity, as the protostar rapidly becomes more evolved, its outflow creates an ever larger cavity until the surrounding gas is eventually blown away, leaving an isolated star. Our observations indicate there is no progressive growth that we can find, so the cavities are not growing until they push out all of the mass in the cloud. So there must be some other process going on that gets rid of the gas that doesn't end up in the star. Now here, again, we cannot overemphasize how much more powerful and efficient are the electromagnetic scavenging effects of the Z-pinch than the unproven, glacially slow, and inefficient processes of gravity-centric cosmology. This has been further emphasized by the insufficient amount of material that astronomers have observed in some stellar nurseries, including the so-called cosmic seeds in the Snake Nebula, which is to say, the amount of material required in gravitational theory to form the observed number of high-mass stars was not even close to being present. As noted in the 2014 press release from the Harvard-Smithsonian Center of Astrophysics, the seeds generally weigh between 5 and 25 times the mass of the Sun. Previous theories proposed that high-mass stars form within the very massive isolated cores weighing at least 100 times the mass of the Sun. These new results show that that is not the case. The team also was surprised to find that these two nebular patches had fragmented into individual star seeds so early in the star formation process. They detected bipolar outflows and other signs of active, ongoing star formation. Now, one important distinction between Wall Thornhill's electric universe model and plasma cosmology is that Wall proposed that star formation and planet formation can happen in the same event, at a timescale exponentially more rapid than astronomers have ever entertained. This radical hypothesis received stunning support about a year and a half ago, when astronomers observed apparent, fully formed planets about the disk of a young stellar object, or YSO, which means a star that is no more than thousands of years old. As noted in the 2024 Universe Today piece, the youngest planetary disks ever seen. The new images show YSO in disks that are Class 0 and Class 1. At these young ages, the YSOs are still in the collapsing and formation stages. A YSO is only a Class 0 object for about 10,000 years, and a Class 1 object for a few thousand years. So finding rings and gaps in the disks around these young stellar objects is a surprising development to say the least. If planets are forming this early in a solar system's life, it challenges our entire understanding of how planets form. Again, I go back to the statement that nature is not in the habit of doing things the hard way. The clearest indication of the underlying electric currents at the heart of star formation is the observation of the networks of filaments of constant width along which stars form, like, quote, pearls on a cosmic string. As I've pointed out ad nauseum, the constant width is only explicable electromagnetically. The chaotic gravitational processes that astronomers have proposed, such as explosions and turbulence to try to explain the constant width, would be required to impose a degree of radial curvature on the filaments, which is simply not observed. And yet, as beautifully demonstrated in this side-by-side image, the constant width, as seen in the example of bead lightning, is a feature of electrical discharge. Before we lost Wall Thornhill a couple of years ago, nearly 2 decades earlier, he was able to get published in the peer-reviewed journal IEEE Transactions on Plasma Science, his paper on the electromagnetic theory of star formation and supernovas. The Bennett or Z-pinch mechanism, which Alfvén proposed many decades ago, is the most promising, experimentally, and increasingly observationally successful mechanism for explaining star formation, and surely many other formative processes at all cosmic scales. However, as Alfvén cautioned, quote, important fields of research, that is, the treatment of the state in interstellar regions, including the formation of stars, are still based on a neglect of Bennett's discovery more than half a century ago. Present-day students in astrophysics hear nothing about it. Of course, today, nothing has changed. Scientific discoveries that have undermined or falsified the standard theoretical model of star formation, while affirming the electromagnetic one, have done nothing to force a shift of perspective in the space sciences. I have to admit that when I look at the current state of our world, With the hand of atomic scientist's doomsday clock now set at 89 seconds to midnight, I cannot say I'm surprised that civilization has yet to find the ideal path toward genuine scientific enlightenment, particularly in a field as apparently remote to human experience as cosmology. Unless or until we figure out the business of conducting human life in a sane, benevolent, and truly humane fashion, our capacity to understand the larger universe and our place in it will surely remain elusive.